Okay, it says the following table shows fuel consumption in billions of gallons of vehicles, yada, 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 yada. It gives you the data, it gives you the equation, and it gives you the graph. It says use the above scatter plot to decide whether the quadratic model fits the data well. Basically, you're just seeing, does the graph seem to go through the quote unquote center of all the points? Yeah, some points are below, some points are above. That's really what you're looking for. So this looks pretty good to me. So this is going to be a good model for the data. And now it says estimate the fuel consumption in 2009. That's going to be in billions of gallons. So this is billions of gallons in the years since 1990. 2009 from 1990 to 2009 is 19 years. So I'm just going to replace T with 19. So I'm going to find F of 19 just by doing the following: negative 0.114 times 19 squared plus 4.62 times 19 plus 127.598. So let's do that in the calculator. So I have negative 0.114 times 19 squared, okay, plus 4.62 times 19 plus 127.598. Looks like 174.224. Just want to double check to make sure I didn't mess anything up there. Negative 0.114. Yep, 19 squared. Okay, good. So 174.224. I don't know how many decimals they want, but I guess that's good enough. Use the model to predict the year in which the fuel consumption will peak. So I'm looking for basically, if this quadratic equation kept going, where is the peak or the vertex? So I'll use the vertex formula. The vertex formula is going to be the x coordinate. In this case, the t coordinate is negative b over 2a. And then if I wanted the y coordinate, or in this case, the f of t coordinate, I would plug that back into the function, f of negative b over 2a. But we can save ourselves some time because it just asks us for the year, and that's just going to be this thing. So if I just want to find negative b over 2a, that's going to be negative 4.62 over 2 times negative 0.114. So we go with that. Negative 4.62 divided, oops, let's get out of there. Negative 4.62 divided by, I'm going to use parentheses, 2 times negative 0.114. Like so. And I get 20.26. But remember, these are years since 1990. So if you don't feel like doing the math in your head, just add 1990 to that. That gives us sometime in the year 2010. Okay, the second equation, let me shrink this, or second problem, sorry. It says here, suppose a sunglass hut has a profit function given by that, where Q is the number of thousands of pairs, and P of Q is in total profit in thousands of dollars. How many pairs of sunglasses should be sold to maximize? Maximize the profit, that's the same thing as finding the vertex, the peak. So we're looking for the vertex. This is going to be a coordinate Q comma P of Q, where Q is the number of sunglasses and P is going to be the profit. So this is just asking for the coordinates of the vertex. How many sunglasses will maximize it? And then what will that profit be? So the first thing I'm going to do is, just like I did in the last problem, is negative b over 2a. Negative 5 over 2 times negative 0.02. Negative 5 divided by 2 times negative 0.02. 125. So it looks like you had that. Maybe you just flipped it. Maybe you just put the wrong thing in the wrong box. So this would be 125. Then to find what the maximum profit is, I'm just going to take 125 and plug it into my equation. Negative 0.02 times 125 squared plus 5 times 125 minus 30. 282.5. So this is in thousands of dollars. $282.5 thousand.